force of interest. Now, force of interest delta measures the instantaneous interest when the compounding is continuous. So up to this point, we have studied compounding, which takes place after regular intervals. But now we are talking about compounding, which is continuous. So this is different from nominal or effective interest situations because there, as we said, the compounding is only at fixed points of time, not continuously. So because of this, we can think of force of interest as the limit of the nominal interest. So if delta is the force of interest, then it's equal to limit m tends to infinity I superscript m. Now, if the annual force of interest is constant, then related to annual, then it is related to, let's fix this, then it is related to the annual effective compound interest rate I as follows. Delta is equal to ln 1 plus I. And from this, we can get I is equal to e power delta minus 1. And remember that force of interest is constant only in case of compound interest. So anytime you're given a constant force of interest, you know that it's equivalent to an underlying compound interest according to this equation, 15.3 or 15.2. So in this case, which means that in the case of constant force of interest, the amount function is a of t is equal to p e power delta t. P is the principal as always, t is the time. Now, in general, force of interest does not have to be constant, but it's a function of time. So in that case, we denote it by delta subscript t. Now, we always have this equation 15.5. So force of interest of any amount function can be obtained by taking the derivative of the amount function and dividing by the amount function. So delta t is equal to a prime t over at. And from this, we can have a of t is equal to p e power 0 integral 0 to t delta r dr. And 15.6 is the most commonly used formula for finding the amount if a force of interest is given. Okay, so let's erase this. Example 15.1. Now, if you are given a nominal interest rate of 10%, which is compounded quarterly, we can still find the equivalent force of interest, although we just have the formula relating force of interest to annual compounding. So we use 15.2 in conjunction with 9.1. Here m is equal to 4. So we have delta is equal to ln 1 plus I. That was 15.2. And 9.1 said that 1 plus I is equal to 1 plus I4 by 4 power 4. And so we replace the 1 plus I by that. And I superscript 4 in this case is 10%, which is 0.1. And so it ends up being 0.0988. So the equivalent force of interest is 9.88% in this case. Example 15.2. You deposit 50 in a bank that pays 4% annual simple interest. What is the force of interest after 3 years? So here we have a simple interest for which the amount formula is P times 1 plus IT. And principal is 50, so it'll be 50 times 1 plus 0.04. T, I is 4%, so 0.04. And when you expand it, you get 50 plus 2t. So use 10.5, which tells us that 15.5, it tells us that delta t is equal to a prime t over at. So this needs to be corrected. It's 15.5, not 10.5. So a prime would be the derivative of 50 plus 2t, which is just 2 divided by at, which is 50 plus 2t. And so we need the force of interest after 3 years. So we need delta subscript 3. So we substitute t is equal to 3 here and get 3.57%. Now, we actually see a very interesting formula kind of from this example. And that is that, look at this force of interest. We had 2 over 50 plus 2t. Now, anytime you see a force of interest of the form k over a plus kt, that basically tells you that the underlying interest is simple interest of k. And this actually will be very useful in the SOA problem that we are going to solve in this lesson. So as advertised, we will also work on SOA problem 252. Fund X accumulates at a force of interest delta t is equal to 2 over 1 plus 2t. So let's try to do this. Okay. And now we see that this is of the form k over a plus kt. So this is actually, there's an underlying simple interest going on of 2. So this coefficient of t, which should be the same as this constant in the numerator. That is the simple interest if you have a force of interest of this kind of form, k over a plus kt. So 2 is the simple interest in this case. And so now actually let's make a correction here. This needs to be not k over a plus kt. If it's 1 plus kt, then we have k as a simple interest. So if even if we have an a here, what that means is we still have a simple interest going on, but the interest would then not be k. So in order to find the interest, you have to change this coefficient into a 1. So now we see here that in this case, since this is exactly of this form, k over 1 plus kt, so now we know for sure that the simple interest is 2, because in this case, the simple interest is k. Okay, and so for x, we recognize that we can use the simple interest formula. So for simple interest formula, we know is 1 times 1 plus it. So x in 20 years would be 1 plus 2 times 20, because we are told that in 20 years, both the funds x and y have the same value. So the first order of business is to calculate what x is in 20 years. So it'll be 1 plus 2 times 20, that's 41. And now, in case you don't recognize that this is corresponding to a simple interest situation, so then you can just use 15.6, equation 15.6 to find x of 20. So let's look at that. So here, then you will just use p is equal to 1, which is the principal in this case, and you would do 0 to 20. And delta r would be 2 over 1 plus 2r, and then you will just integrate that and find the value, and that will also come out to be 41. Okay. So we are told that y also accumulates to the same amount as x does in 20 years. So y has compound interest of y accumulates at an annual effective interest rate of I. Remember, whenever we have a constant annual effective interest rate, that's corresponding to a compound interest. So for y, the equation would be p times 1 plus I power t. P is 1 in this case also. Both have starting principles of 1. So y at 20 would be 1 plus I to the 20. We are given that x20 equals y20 as mentioned. So 41 will be equal to 1 plus I to the 20. Now you take the 41st root on both sides to get 1 plus I is equal to 1.204. You don't have to calculate I, because the eventual goal is to find the y after 5 years. So y of 5 would be 1 plus I to the 5 according to this equation. And now you can just substitute the 1 plus I value, which was 1.204. So it'd be 1.204 to the 5. That's 2.53, and that is choice B.